Good morning, chemistry students. Here are your Chapter 14, Day 1 notes. We'll be starting at Section 1, Classification of the Elements, and finishing up the element classification according to electron configuration, number 1. So Section 1, Classification of the Elements, we're going to kind of revisit or kind of talk about again the development of the periodic table. Remember that the first scientist given credit really for kind of our modern periodic table was Dmitri Mendeleev. Mendeleev arranged the elements in his periodic table in order of increasing atomic mass. Remember that he did his work before they knew about protons, electrons, and neutrons in the atom. So he used atomic mass. He realized that his periodic table was probably not correct, and he actually left some empty spots for elements that had yet to be discovered. The periodic table today, in the modern periodic table, the elements are organized in order of increasing atomic number. So remember, and we've seen this, we've already been using this, right? That our periodic table today has all the elements in order by atomic number. Remember, the atomic number is telling you the number of protons in the nucleus of an atom. In a neutral atom, it's also telling you the number of electrons. There's also something called a periodic law, which says that when the elements are arranged in order of increasing atomic number, there is a periodic repetition of their physical and chemical properties. When we originally talked about this, we talked about the fact that that ends up being that elements that have the same properties as one another, so they look like each other, they act like each other, these tend to be in the same column or group or family on the periodic table. In terms of actually reading your periodic table, what kinds of things do we find on the periodic table? So the periodic table usually displays the symbols and names of the elements along with the information about the structure of their atoms. And remember that structure of their atom information comes from the actual physical shape of the periodic table, the two tall columns on the left, which are our S block, the 6 tall columns on the right, which are our P block, the 10 short columns in the middle, which are our D block, and the 2 rows pulled out and put underneath the periodic table, which have 14 in each row, which are our F block. Also, some of the groups on the periodic table do have some special names. There are the alkali metals. Okay, those are the elements of group 1A, or 1, depending on how your periodic table is labeled. There are the alkaline earth metals. These are the elements of group 2A, or 2 on our periodic table. And finally, there are also the halogens, which are the nonmetals of group 7A. So, just some information that's always on our periodic table. So, classifying elements by their electron configuration. Okay. We have kind of talked about before the fact that the electrons play a key role in determining the properties of the elements. So there should be a connection between an element's electron configuration and its location on the periodic table. So there are lots of different ways that you can sort the elements on the periodic table. We're going to talk about one way. So we're going to talk about the fact that our elements can be sorted into noble gases, representative elements, transition metals, and inner transition metals, based on their electron configurations. So again, we're going to be using what we did in the last units where we wrote those electron configurations, like helium's being 1s2, to classify where an element is on the periodic table. So element classification according to electron configuration. The first kind of category or group that we're going to sort these into are the noble gases. These are the elements in group 8A of the periodic table. The noble gases are all nonmetals, and they are sometimes called inert gases because they rarely take part in reactions. So typically noble gases will not be very involved in chemical reactions. So what we want to do is look at the electron configuration of the first four noble gases. So I'm going to give you a couple minutes. I want you to write those electron configurations. So that's like that 1s2, 2s2, that type of stuff. I want you to write the electron configurations for helium, neon, argon, and krypton. And the best thing for you to do might be to pause your video while you use your periodic table to do this. So helium has electron configuration. Remember, you're reading your periodic table starting at the top left corner. It's 1s2. For neon, it's 1s2, 2s2, 2p6, because neon has 10 electrons. Argon has 18 electrons, so it's 1s2, 2s2, 2p6, 3s2, 3p6. Finally, krypton has 36, so it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Next, remember we come to the 3ds because they're one behind 10, and then 4p6. So that's our electron configuration of our first four noble gases. What we want to kind of notice about these is the highest occupied energy level, which we're going to refer to quite a bit, so I'm going to kind of use this HOEL abbreviation. So what I'm going to do is I'm going to underline in red the highest occupied energy level. Remember, that's going to be the highest number. So in helium, it's just the 1s2. In neon, it's 2s2, 2p6. In argon, it's 3s2, 3p6. And in krypton, it's 4s2, 4p6. So that is our highest occupied energy level. What you should notice about all of those is that the S and the P sublevels are completely filled with electrons. For all of them except helium, there are 2 electrons in the S sublevel and 6 electrons in the P sublevel. Remember, an S sublevel can only hold 2 electrons because there's only one S orbital. A P sublevel can hold 6 electrons because there are 3 P orbitals, each holding 2 electrons. It is because of this arrangement of electrons is related to the relative inactivity of the noble gases. So it's the fact that this highest occupied energy level is completely full for the noble gases. That is why they don't get involved in chemical reactions. They don't tend to form chemical bonds. It's also going to be why when we start to talk about bonding and such, that we're going to talk about the fact that every element on the periodic table is doing what it's doing in an effort to be like the noble gases. I often refer to the noble gases as kind of the cool kids of the periodic table. All of the other elements on the periodic table, when they get involved in bonding, they're going to be doing so in an effort to be like the noble gases. And that is all I had planned for today. So enjoy your shorter day of notes. It doesn't happen very often. Have a good day. I will talk to you tomorrow.